In this video, I will explain you how to solve number 5, question 5 in lab 6. In question 5, we have another true dip parent dip question. This time, you reverse all the steps you applied in question 4. Instead of plot, in question 4 you plot a bedding coal seam, which is a bedding plane, and then you find a parent tip of this bedding plane in 3 different directions. In question 5, now we have the strike orientation of the bedding plane, but we don't know true dip, we don't know dip direction or dip angle of the bedding plane. Instead, we have a parent tip of this layer as 30 degrees to the north, measured on a vertical cliff striking north 10 east. So now we will use this information and try to find true dip. In the question asking the amount and direction or bearing of its true dip, which is also known as dip direction. That's another type of measurement we collect. So first, let's set up our tracing paper. I will mark directions as north, south, east, and west. And we know strike orientation of bedding plane is north 50 east. So first I will mark this strike orientation because I will need it. So north 50 east will be in northeast quadrant, and this strike azimuth point will be 50 degrees off of the north. So as we start from north 10, 20, 30, 40, 50. So here at this point we are at north 50 east strike azimuth point. Right? And what else do we know? We know the orientation of this vertical cliff. So this vertical cliff is striking at north 10 east. So next we need to show this vertical cliff, which is the traverse. We collected this apparent dip measurement. So north 10 east is at this point. Because it is a vertical cliff, that means this measurement will have a 90-degree dip angle. So we can move this strike azimuth point of vertical cliff to the north and draw this straight line going through the center of the projection, because all vertical planes will make a straight line going through origin of the stairnet. So now, and also here we know dip angle is 90 degrees at the center and it's 0 on the other circle. So now we have this vertical cliff as a straight line going through north 10 east direction, and we know strike azimuth point of the bedding plane. And what else do we know? We know apparent dip of this bedding plane in this direction, measured in this direction. So this is the direction of observation. So we observe this layer in this north 10 east direction, and it appeared as a layer dipping at 30 degrees to the north. So let's plot this 30 degrees to the north apparent dip point along this traverse. So let's move this line back to north-south reference line and count 30 degrees from north, because we have that information in the question. So 10, 20, 30. And let's mark this point. I will label that as A. That's A point. A is apparent dip point. Alright, now we this apparent dip measurement, because it belongs to this same plane, now we have 2 points belong to the same plane. So these 2 planes are contained by the same plane. So how can we find this plane? So basically we are looking for a great circle which will go through this point A, and and then it will connect to this strike point at one side. So let's rotate our um, tracing paper and move this strike azimuth point to north-south reference line. Now there will be only one great circle corresponding to this point and connecting to north 50 east strike azimuth at the north, and which is right here. You can see if you draw that great circle and connect that great circle to the north 50 east strike azimuth, now we found a great circle that is going through this apprentice point and connecting to strike azimuth point of the same plane. So these 2 points are contained by the same great circle at this point. When you keep this paper, tracing paper at the same position, because we want to count tip angle of this great circle, and you can do that here between other circle and great circle. Count these great circles. So it is 10, 20, 30, 40. It's maybe 42, 44, something like that. So 42, 44. We will accept some. We have some error window to accept answers. So if you say 48, it is too much error. But if it's between this range, 42, 45 range, it will be acceptable. So now we know. Also, I will mark this direction on the other circle. We can rotate tracing paper back to original position. Rotate back to north. Now you know the dip angle of this great circle, which is 42, 45 degrees. That's the true dip of the bedding plane. And also the amount of direction of true dip. So this is the direction of true dip. You can read this strike azimuth point on the other circle. So here we have 270, 280, 90, 300, 310, 320 or 318 or 318 or 320, something between these two numbers. You can give 320. That's the orientation of true dip. So that's the bearing of true dip. And the amount of dip, so how much this bedding plane tilted or inclined, that's 42, 44. So after you find these two components, it's not done yet. You have to give us a complete measurement. Because this is a plane, we'll start with strike azimuth, which is 320, and then we'll add dip angle as I'll just say 42. So this is the complete measurement, and this way you can find true dip. By the way, this is dip direction measurement. This is not the strike of bedding plane. This is the orientation of dip direction. This is different. So the strike of the bedding plane is already given in the question, so it's north 50 east. This is the strike of the bedding plane. So this direction, which is 220, is the direction of dip, which is 90 degrees to the strike orientation.